Everyone, welcome back to our channel. Today we are diving into the world of time series analysis and exploring classical decomposition. If you have ever wondered how to break down a time series into its fundamental components, then this video is for you. We'll go step by step through the classical decomposition, so stick around. For this, I am using book of Reza Hoshman, Business Forecasting: A Practical Approach, and this topic is in chapter 4, page number 69. So, what is classical decomposition? Classical decomposition is a method used in time series analysis to break down data into four main components. And these components are trend, seasonal variation, cyclical variation, and random or irregular variation. Trend is the overall direction in which the data is moving over the period of time. Seasonality um, refers to the patterns that repeat at regular intervals. Cyclical component is the longer term fluctuation that don't have a fixed frequency. And irregular or residual components, the random variation that remains after removing the other components. The key idea behind classical decomposition is to separate these components so we can better understand, model, and forecast our time series data. For this, we will first pre-process the data, that is, collect and visualize the data. So we have got sales data in 1,000 liters, and this is for 6 years and 4 quarters for every year. So first, what we'll do, we'll just rewrite the data in a format in which we can visualize this vector. So these are quarter 1, 2, 3, and 4. So we'll just copy all the data. This is 2010. This is 2011. Quarters and sales. So I've already copied all the data here. First we will identify the pattern. Insert graph. So we get this graph. Okay. By looking at the graph, we now know that the data has seasonal variation, same patterns repeat itself over the same period of time, and a trend over the period of time. So I will just keep this graph. I will keep all the graphs separately. Okay. Now the next step is to identify the trend component. So there are multiple ways we can do this, but one common method is to apply a moving average. If a data has a seasonal component, we usually take centered moving average. So we have quarterly data. We will use 4 quarters moving average followed by 2 quarters moving average to identify the trend component. So we'll take average 4 quarters. Just copy this number. We have to check that all 4 quarters are available. Now it will be followed by a 4 quarter moving average, and now we'll check 2 quarters moving average. Okay, we'll check. We'll test it into formatting along. Okay, and if I may enter a row here, so this is sales data, actual data. This is trend. Now we have to detrend the data, which is y minus t. So we have minus actual data minus trend. Now if we plot this data in a graph, so we have seasonality left in this data, and we have removed the trend component, right? So I'll just move this chart at the end of this page. You can also name the charts or the graphs. Okay. So we have now de-trended the data. The second next step is to identify the seasonal component. For seasonal component, we have to create a seasonality index. Now we have 4 quarters data, and quarter 1, 2, 3, and 4, and over the period of 6 years. So I'll write down the years, 2015, right? Okay. Now for season indices, we will write all the seasons. So we have first season available in quarter 3 of 2010. So I will copy these two third quarter and fourth quarter data, and then first quarter, this dividing, and then 2012 we will copy all the seasons year wise, 2013, and then 2014, and for 2015 we have last 2 quarters data, quarter 1 and quarter 2. So this is our data. We have covered all quarters and for all the years, right? Now we will calculate mean, or unadjusted variance is equals to average. Okay, so for this is additive model, the sum of means must be equal to 0. So we have some sort of a difference in this data. I'll just make some boundaries to make this data in readable format. So now we have a difference. What we'll do, we will divide this difference in all the quarters, right? So this is adjusted seasonal index. What I'll do, I will just add the difference and will minus the difference from the data. Now the ending balance is 0. Now we have created the indices. We'll just copy indices. Okay. So we have all the quarters, quarter 1, 2, 3, and 4. We'll just copy values for all the quarters and for all the years. Right? Season index is done. Now, after computing the season index, we adjust them so the average equals to 1 for the multiplicative model and 0 for additive model. Now, we'll just deseasonalize the data. This is S and we will do Y minus S is deseasonalized. So we will actual data and deseasonalized data. So if we plot this, what we'll get is if we plot this data, we'll get only the trend component. To make the data more readable, I will just yeah. So now we can see only the trend component in the data and no seasonality. And just keep all the graphs together. So now we have detrended the data, deseasonalized the data. Now we'll identify the irregular component. So the formula for identifying the seasonality is y is equals to trend plus seasonality plus irregular component. So in this equation we have y, p and s. For irregular component y minus t minus s. So y minus t minus we've got the irregular component or the errors or random variation in the data. And this graph as well. So all the graphs are kept together. Mm. So irregular component should ideally be random, meaning there's no identifiable pattern left. If we notice a pattern, it may indicate that our decomposition didn't fully capture the trend or season. For this data, the irregular component is completely random. There's no pattern in this. So, and that's how you perform classical decomposition on time series data. Let's quickly recap. First, you have to visualize the data, then extract the trend using moving average, then compute the seasonal component and conclude irregular component. The next step will be reconstruct and forecast that we'll be doing in the next upcoming video. Thank you. Bye bye.